Hello everyone. We are going to be looking today on natural logarithmic functions and we will be focusing on integrals. The topics we will be covering is using the log rule for integration to integrate a rational function and also integrate some trigonometric functions. Let's look at the log rules for integrals. Remember, if you use a differentiable function of x, then the differential of natural log of x is 1 over x and x has to be positive. Or if differential of natural log of u is taken, it is 1 over u times du over dx, which is the same as if you notice this one, it is the same thing as having 1 over u times u prime, which is basically u prime over u is positive. Now, we know that integrals and differentials are opposites of each other. So the same differential rules can be in the way we can write it in terms of the integral rules. So here, if you use a differentiable function of x, then the integral of 1 over x dx. Now this x can be any number, any real number. Natural log of absolute value of x. Very important because natural logs or logarithms cannot accept any numbers, any negative numbers. We know that even it cannot, definitely it won't be taking a 0, 2, and this won't be a 0, 2, plus a constant. Or if you're having 1 over u du, then it's a natural log of u plus c. Now notice, we know use a differentiable function of x. That means du over dx is u prime. Do you see that? So I can write my du as u prime dx. And then it basically gives me natural log of u plus c. Okay, now let's practice what we have just learned about these rules. I'm going to do some examples. Now, the first one, remember, it's integral of 2 over x. Now 2 is like a constant, so I can pull the 2 out, and what do we have? 1 over x dx. And the formula for anything 1 over x dx we just learned is natural log of x, but remember to put the absolute values and plus a c. That was pretty simple. Okay, let's look at the other another example. So you're going to have an integral of 3 over x plus 5 over x cubed. Now the first one, it's an integral of sum of functions, so we can have this as 3 outside 1 over x dx plus 5 outside, and we can take the cube on the this x cube being now in the numerator, so it's going to be x to the power minus 3 dx. Now the first expression we all know is 3 natural log of absolute value of x plus 5. Now integral of x to the power minus 3. You're going to simply apply your power rule, guys. X to the power minus 3 plus 1 over minus 2. That's the same thing goes down. And a plus c. So a final answer, just clean it up. What you have, 3 natural log of absolute value of x minus 5 halves x to the power negative 2 plus c. Okay, let's look at this example, which is integral of 4 over x plus 6 dx. Okay, it's not like the usual we had an x only in the denominator, but we have an expression of 2 terms, x plus 6. If you guys remember the u substitution, that's the most important thing in integrals. So if we change this, we say let u be equal to x plus 6. So what's my du? Simply tx. So this whole expression inside in the given integral is now going to be in terms of u's. So the expression now here is going to be equal to 4 du over u. Now we all know that this is 4 outside 1 over u du, which is 4 natural log of u. Now remember, our original problem was in x, so we got to change the u back to x. What do we get? 4 natural log of x plus 6, and the final answer should have a c because we are doing indefinite integrals. Okay, now let's increase the intensity of our problems. Here we have an integral of x squared over x cubed minus 4. Now remember guys that we just had, that u prime over, u prime over u. So if you have integral of a, if you have a differential of a function over the function, so that means you can use the u substitution. So that is the key, guys, we have to keep in mind. So if you look at a rational function, so here are the hints. If you see a rational function where either the numerator or specifically the numerator is a differential of the denominator, that means you are going to have natural logs. Okay, so let's look at this one. So you say u equals x cubed minus 4. So what is my du? 3x squared dx, or du over 3 equals x squared dx. Now, let's go and make the substitution here in the original problem. So this one will be now equal to x squared dx is du over 3, and we have 1 over u. So to solve this one, what do we do here? This is equal to, we can take 1 over 3 out, 1 over u du, and we know that anything with the variable with the power 1 is now going to be natural logs. So it's going to be 1/3 natural log of u plus c. Or remember, the final answer has to be in x. The variable x, it's going to be x cubed minus 4 plus c. Okay. Let's look at the next problem. You have an x squared minus 2x, and in the denominator, x cubed minus 3x squared. So the first thing should always be, oh, can I do u substitution? Oh yeah, because the differential of a cube is a square and a differential of a square is an x. So we have both of the terms in the numerator, which are differentials of the denominator. So let's see if it works. So you say u be x cubed minus 3x squared. So my du is what? 3x squared minus 6x dx. Now notice, in the numerator in the problem, we have x squared minus 2x. So here we have 3x squared minus 6x. So, and I notice 3 is common in the du expression. So if I take 3 out, what do we get? X squared minus 2x dx. So du over 3 now equals x squared minus 2x dx. Now if I can make the changes in the original problem, what are we going to get? We're going to have now x squared minus dx is du over 3, and what is left is 1 over u, which is basically 1 over 3 natural log of u. Remember putting absolute values, please, plus c. So final answer, 1 over 3 natural log of x cubed minus 3x squared plus c. Okay. Now let's look at this last problem in this slide. Here we have a square and a 5, on the numerator. If I take the differential of a square, I get an x. But what will I do with this x5? So we're going to take another approach. And the approach is, if we have only one term in the denominator and more than one terms in the numerator, we will separate the numerators. Okay? So we're going to write this as x5 over x squared minus 7x over x squared dx. So now apply the exponent rules, x cubed minus 7 over x dx. Now we know how to solve this one. So it's a pretty simple one now. So integral is now x4 over 4 minus 7, it is 1 over x, remember, natural log of x, plus final answer with a c, plus c. So these were polynomials and we were having rational functions over here. Now we are going to look at some trigonometric functions. Now, integral of tangent x dx. Doesn't seem, but if we replace the tangent with a sine and a cosine, then something might show up. Okay, tangent is, we all know, sine x over cosine x dx. And then notice, differential of a cosine is a sine. So we say, let's do u here. Say u to be cosine x, du to be negative sine x dx, or minus du equals sine x dx. So our original problem is now going to be changed into negative outside du, sine x, remember sine x dx, I'm sorry, this was the one we're going to work with, minus du, and we'll write on the final answer of the integral there. So sine x dx is a minus du and over u. So what do we get here? This is equal to negative natural log of absolute value of u plus c, and the final answer, replace the u by the substitution we had in terms of x. It's negative natural log of cosine x plus c. Okay, let's look at the next problem. Here we have sine x squares and cosine x squares. So let's look at, if I take the differential of the denominator, do I get the numerator? Because that's the only option here. Okay, so u, if I take it to be sine x squared plus 2. So what's my du? Remember, it's going to be a chain rule. It's going to be cosine x squared, matching the top, times 2x dx. So we exactly almost have the same thing. The only thing is 2 is extra out. So we say, hey, du over 2 is x times cosine of x squared dx. So we can change the original problem in terms of a u. So it's going to be du over 2, and so 1, because x cosine x squared dx is du over 2, and then 1 over sine x squared plus 2 is a u. So what do we get? So this one is half natural log of u, and the final answer, when you replace the u by this variable, the substitution we did earlier, sine x squared plus 2, and then, a c. So this was some trick. Let's look at some square roots. And how do we do the square roots? Now over here, notice what we're going to do is we're going to say, hey, let u, because the only option is we do not know anything else to place, just use substitution. So see what we get. 1 plus square root of 3x. Okay. Now what is my du? Du is, now notice this is what? 3x to the power half. So it's half 3x to the power minus half, or dx, or I can write this as half times square root 3x dx. Okay. Now, notice, so what we have done is, oh, and I forgot, times differential of 3x too. I remember it's a chain rule, guys, I forgot. Times 3 differential of 3x dx. So we have 3 over 2 dx over square root 3x. Okay, so if I start making changes here, so it's 1 over u. Okay, and what is my dx? I can write my dx as 2, okay, over 3 square root 3x. Okay, so when we write that, so we have 2/3 square root 3x and a du, I forgot, guys. Du. Okay, 2/3 comes out. We have 1 over u, but we have a square root 3x. Remember, we have to have everything in u. So now let's go back and see what is square root of 3x in terms of u. So when I come back over here, notice square root of 3x is nothing but u minus 1. So here u minus 1 is square root of 3x. Okay, so now we can have everything in u. It is u minus 1 over u du. Now remember, there's only one term in the denominator. What do? We separate the terms in the numerator. So it's u over u minus 1 over u du, which is 2/3 1 minus 1 over u du. So when we do the math, it's 2/3 u minus natural log of u with the absolute value and a c. Now remember, you have to change the u back in terms of the substitution. So what we're going to have here, so the final answer is 2/3 u, remember, is 1 plus square root 3x, then minus natural log and absolute value of 1 plus square root of 3x plus c. Okay, yeah, quite a little things we have to do over here. Okay, now let's look at another kind of a problem here. Over here we have an expression, a rational expression where the denominator has more than one term and numerator already has more than one terms. Now if I take the differential of the top, I will not get anything in the denominator, because even if I take the differential of x squared, I should get 4x plus 7. So that also kind of u prime and u's will not work. But if you play something else, so here's the third scenario to play with. If you cannot have a u prime over a u scenario, or you do not have one term in the denominator, the other option is, let's try long division and see if it gives an answer. Okay, the long division is here. So we could actually literally divide this. X minus 2, 2x squared plus 7x minus 2. Okay, so how are we going to write this one? So you're going to go ahead, cancel first 2x squared. So you need a 2 because that's missing x. So you get 2x squared minus 4x. So we change the signs, minus with a positive, cancels out. We have 11x minus 2. Now we need to cancel the 11x. There's an x, so you need to have an 11 over here. So we put positive 11, you get 11x minus 22. Remember, this has to be multiplied over here. So then you change the signs. What are you left with? 20. So notice, how can we write this expression? We can write this expression 2x squared plus 7x minus 2 divided by x minus 2 is equal to the quotient 2x plus 11 plus the remainder divided by x minus 2. And that's exactly what we'll change. The long division will make our life simple because now I can do my integrals easily here. So now this expression becomes 2x plus 11 plus 20 over x minus 2 dx. Now, the first two terms, easy, right? It's an easy thing. So that would be what? 2 times x squared over 2 plus 11x. Now plus 20 out and dx over x minus 2. We did a similar problems around some few minutes ago. Now here we will do the u substitution. Okay, so over here you can say let u be equal to x minus 2. So what is du? dx. So plus, this would become this side. So integral dx over x minus 2 is now integral du over u. That means it's natural log of u. So when I make the changes here, so what do I get here? I get x squared because this 2 and a 2 cancel out, plus 11x, and from here plus 20 and natural log of u. Now remember, you got to replace the u by x minus 2 because the whole answer should be in x's. So x squared plus 11x plus 20 natural log of x minus 2 plus c. Okay, now let's look at a problem from a different perspective. Now these are definite integrals. If you remember in chapter 4, we learned how to, write down the area of the region in terms of the expression, in terms of integrals and stuff. So that's what we're going to do. So it says find the area of the region bounded by the graphs of this equation. Y equals this, x equals 1, x equals 4, and y equals 0. So if you look at this x squared plus x, this function, guys, actually looks like this. Something like this. So we would like to have the area under this curve from 1 to 4. And that's what we like to know. And this is x squared plus x over 4. So what you basically do is, first of all, write down that as a definite integral. X goes from 1 to 4. This, remember, is your function f of x. X squared plus 4 over x dx. Y equal to 0 means the x-axis. Okay, now this one, as we have only one term in the denominator, and we can actually separate the numerators. So how would this look like? Now it's going to be 1 to 4 x squared over x plus 4 over x dx. This will be equal to 1 to 4 x plus 4 over x dx. Now, remember, you're going to apply the first fundamental theorem of calculus. In other words, we are simply just going to do the indefinite integral. And that's how we're going to write. This is going to be what? X squared over 2 plus 4 over 1 over x is simply 4 natural log of x, remember? And then that's my function. That's the entire derivative. And 1 to 4. And then we just plug in the values. Remember, this, guys, is your capital F of x. That's the antiderivative. Okay, that means we have to do f of 4 minus f of 1, which basically is 4 squared over 2 plus 4 times natural log of 4 minus 1. Now remember, these are two terms, so I'm going to put brackets. 1 over 2, 1 square is 1, plus 4 times natural log of 1. Now remember, natural log of 1, guys, if you remember, is a 0, but natural log of 4 will be a value, and so what do we get? So this is 4 squared, that's 16, so this is going to be 8 plus 4 times, some value which is going to be natural log of 4. I'm trying to see what would be that. So let's leave it like that at this point. And this will be minus half. And then what is this going to be? 8 minus half is what? 7.5. Plus 4 natural log of 4. Remember, you don't put a c when you have definite integrals. Keep that in mind. Okay, let's look at an example of natural logs and e's inside our definite integrals. Okay, so in this problem, guys, you have to think, okay, what should be my u? Because there is no way we can actually divide this term 1 over x plus natural log of x over x, But think of this, what would be the u substitution which was going to make our life easier? The thing is, that if u is natural log, we know the differential of natural log of x is what? 1 over x. That's going to be the key for us, okay? So we can write this expression, first of all, to make our life easy, 1 over e, 1 plus natural log of x squared times 1 over x dx. So if I make my u substitution, can I make my life simple? That's the main idea. And you see, yes, because if I take u to be 1 plus natural log of x, okay? Oh. And my du is 1 over x dx. Okay, now remember, we are doing u substitution over here. As we're doing u substitution, that means we will also have to make changes in the limits of the intervals. So when my u is 1, x is 1, this is the meaning when x is 1, remember that. So when my x is 1, remember this is for x equal to 1 and x equals e. So when my x is 1, what is my u? U is 1 plus natural log of 1. And we know natural log of 1 is a 0. So it's 1 plus 0, it's a 1. Okay. When my x is e, what is u? U is 1 plus natural log of e. If you remember, natural log of e is a 1. So it is 1 plus 1, which is 2. Okay, let's write it down. Equals. We're going to replace everything in u's now. 1 to 2. Now remember, this is u goes from 1 to u goes to 2. 1 plus natural log is simply u squared. And 1 by x dx is a du. It's so simple now to do the problem. The main difficulty is, how do we look at the problem and what are the ways we can play with it? So now let's go ahead and finish it. So what's u squared? U cubed over 3, that's the antiderivative, and 1 over 2. So this, guys, is my f of x, which is f of 2 minus f of 1, which is 2 cubed over 3 minus 1 cube over 3, which is what? 8 minus 1 is 7/3. Do you see that? Okay. Now, let's look at a problem from a different perspective. Now, if you remember, we've talked about how the solutions of a differential equation. We did this early on. So what is the solution of a differential equation? It simply means what value of y will satisfy, that's the meaning. Find the solution is what value of y will satisfy this differential equation, the star. So in other words, we have to find y. Now, in order to find y, what we're going to do? We're going to integrate this problem. Remember, integrals and differentials cancel out each other. So the integral of d dx of y is the same as the integral of x minus 2 over x dx. So remember, the integrals and the differentials cancel out. So what do we get? Is a y. And now this part is only one term, so it's going to be x over x minus 2 over x dx, which is integral 1 minus 2 over x dx. And now we already know how to solve this one. This one is 1 is x minus 2 over x, we already know is natural log of x plus c. So we have got the solution y equals x minus 2 natural log of x plus c. The question is, find the solution at the point minus 1 and 0. In other words, give me a particular solution. That's what I'm saying. So in other words, you plug in the values of x and y and you get the value for c. That's what it literally means. Okay, so what's the solution at the point minus 1 and 0? Plug in the values, you get 0 equals minus 1 minus 2 of natural log of minus 1. It doesn't matter, it's an absolute value, plus c. We get minus 1 minus 2 natural log of 1 plus c. We know natural log of 1 is, guys, a 0. So you get minus 1 plus c, or c equals 1. Now, what we do over here is we write the solution now. The solution y is x minus 2 natural log of x plus 1. A reminder, guys, that when we are writing y in terms of a constant, this is called a general solution. So first time when we find the solution, basically we are saying give me the general solution of the differential equation. So this is going to be dE, okay? And when we find out a specific value, that means this, it simply means we are talking about, this means a particular solution, the ways questions can be framed, of the differential equation. Okay, guys? So we have done a variety of kind of examples for our integrals of natural logarithms. So as usual, what do? We have to practice. So here are 2 slides for you to practice, and I have picked up questions very similar to the ones I've done as examples. Make sure you practice them. Slide 12 and slide 13 are all similar kind of problems we have done before. Thank you.